Given a light source, the scene is rendered from the light source's viewpoint and discretized into the multi-layer depth map. For each scene point sampled in the multi-layer depth map, the occlusion degree is computed through back projection and stored in the so-called multi-layer soft shadow map. When the scene is rendered from the camera's viewpoint, the occlusion degree of a scene point is computed by filtering the multi-layer soft shadow map. A scene is extracted in multiple depth layers and packed in a depth map texture. A depth map sample contains multiple depth values. Multi-layer soft shadow map is constructed using the depth map. The two maps have the same structure, but the depth map contains a depth value per discretized scene point, whereas the multi-layer soft shadow map contains its occlusion degree, which represents how much of light is occluded. The multi-layer soft shadow map construction algorithm processes a sample of the depth map at a time. The depth values are retrieved from a sample, and a rectangular micropatch is placed at a scene point corresponding to a depth value. The potential occludees affected by a sample are all located within the shadow extent of the sample's micropatch, which is closest to the light source. A kernel is a region in the depth map containing the potential occludees. For each potential occludee in the kernel, we compute the occlusion degree caused by all micropatches of the sample under process. For computing the occlusion degree, the micropatches are back projected from the potential occludee to the light plane. The occlusion degree is determined using the overlap area between the back projected region and the light source area. When multiple micropatches are back projected, we collect those that overlap the light source, choose the one closest to the potential occludee, and take its occlusion degree. Now, here are the soft shadow results.